This is lesson 5.4, slope-intercept form. It's probably the most recognizable form for math students for equations, and the one they most likely, after being through high school mathematics, can actually graph. So this one's like an oldie but a goodie. It's like, like just one that's just extremely well known. Okay. So the goals are I can graph linear equations in slope-intercept form, and I can interpret what slope and y-intercept represent in real-world problems. So we'll get a little bit of application here at the end of this. So the slope-intercept form, it simply says, when it says it's in a certain form, that just means that the equation is organized in a certain fashion. So the form, or the organization you're going to see, is you're going to see y by itself, then an equals, and then some value, particularly. The only reason you wouldn't see a value there is if it were 0 or 1, okay? But you'll see some number there, a fraction, and then the variable x, and then plus or minus, and you'll see another value there in place of the b, okay? So m is the slope of the equation, and b is the y-intercept. And so we're looking to graph these things based on the slope and the y-intercept, just like we did in the last section, where I gave you things like a y-intercept or a point, and then you had a slope that told you how to move. So the slope, or m, I like to think of meaning move, meaning that's how you're going to move from point to point on the line, okay? And plotting points along the way. And then I like to think of the b value as meaning begin. So it's going to be the beginning point on the y-axis, okay? So you're going to begin at the b value, and then you're going to move from that point to another point on the line, and then you can plot your line. So just looking down here, I want you to circle all the equations that you think are in slope-intercept form, and then name the slope and the y-intercept. So I'll just go ahead and do one here. I'll say that's slope-intercept form, and the slope is -5, and the y-intercept is 2. So you see if you can find some other ones there. Stop the video and give it a try, and start it back up, see how you did. So here's another one here. I know the y equals is on the right side, but it's still slope-intercept form. Okay, so the slope is the 3/2, and the y-intercept is the 1. And here's another one. Slope is 4/5, and the y-intercept is -3. Here's one here. The slope is negative, and then there's a 1 there, so -1. We don't write the 1, but it's understood to be there. And the y-intercept is 2, and then believe it or not, this is actually slope-intercept form. The slope is 0, and the y-intercept is the 5. Okay? So, how do you graph slope-intercept form? Well, first of all, you want to try and write the equation in slope-intercept form. Sometimes, like these other equations, they're not in slope-intercept form yet, but you could put them in slope-intercept form. So you want to put it in slope-intercept form if that's what you're choosing to do. Then you want to identify the slope m and the y-intercept b. Then you're going to begin on the y-axis by locating the b value and putting a dot there. And you want to make slope into a fraction if it's not already. If you can put it over 1, like if you have a slope of 5, you can make it 5/1. If the slope is negative, then let the numerator, the top number, be the negative, okay? And with your pencil on the y-intercept, so you're starting on the y-intercept, you're going to move up or down. Positive if the top of the fraction is positive. So, excuse me. Up if the numerator is positive, and down if the numerator is negative. And then you're going to move right the value of the denominator and draw a dot. Now you can completely reverse that process. So like if you had a slope of 5/1 and you were going to go up and right, that is the same as going down and left, okay? So you're going to end up back on the line if you go in the complete opposite direction. Up and right is the same as down and left, okay? Or if you have a negative slope, down and right is the same as up and left, okay? You can always just completely reverse that slope, all right? Sometimes you have to because you run off the graph and you can't place a point, so you got to go in the opposite direction. So then you just switch both directions, okay? Repeat the counting to place more dots. Connect the dots. They should form a straight line. If they don't form a straight line, you've made a mistake somewhere, okay? So here's an example. Y equals 6/5 x minus 2. Well, that is slope-intercept form. The slope is the 6/5. The y-intercept is the -2. So I'm going to place a dot at -2 on the y-axis. Well, then the slope of 6/5 is already a fraction, okay? And it's not negative, so the direction's up and right. So from my y-intercept, I'm going to count up 1, 2, 3, 4, 5, 6, and over 1 to the right, 5. And then I can do that again if I want. I can count up 6, you go over 5 again, I get another dot. Now look what happens if you go in completely opposite direction. If you went down and left, what would happen? I can count down 6, 3, 4, 5, 6, and left 1, 2, 3, 4, 5, and magically I end up on the same line again, okay? And there we go. Nice arrowheads. Those lines go on forever. Okay. All right. Example 2. It's in slope-intercept form. The slope is the -1 because there's no number there. It's a -1. If the x wasn't there, it'd be 0. But if there's just an x with no number, it's a 1. And then the y-intercept is +2. So we're going to place the y-intercept at +2. Slope, I'm going to make into a fraction. So they put -1 over 1. It is negative, so we're going to make the top value negative. So down and to the right is our direction. So I'm going to go down 1 and right 1, and man, I can do that all day long, but there's no reason to. Let's just make sure we get a good line on there. Going down and right. Yeah, there we go. And up. There. Nice line. Notice up and left got me to the same point, right? Up and left gets me to the same line, right? Okay. Example 3. So we've got y equals -5x plus 3. That is slope-intercept form. The slope is the -5. The b is the +3. And I'm going to start at +3 on the y-axis. And my slope I'm going to make into a fraction by putting it over 1. It is negative, so that says to go down and right, or up and left. I'm going to go down 1, 2, 3, 4, 5, and right 1, and down 5 and right 1. And that looks pretty good right there. Okay, your turn, I think. So, give these two a try. Stop the video. Start it back up when you're finished. So I've got slope, M is 2, so I'm putting 2 over 1. And the b value is 1, so I'm going to start at 1. And my slope tells me up and right. So up 2, right 1, up 2, right 1. I could go down and left instead. And there's my line. For this one, the slope is 1/2, and the y-intercept is -3. So I'm going to go down to -3. My slope tells me up and right. Up 1, right 2, up 1, right 2, up 1, right 2. And there's my line. Horizontal and verticals. Well, horizontal lines have a slope of 0, and vertical lines have an undefined slope. Horizontal lines are always of the form y equals a number. So like I want to graph the line where y is 2, for example. Well, if I graph the line where y equals 2, I'm literally saying that I can go anywhere I want on the x-axis as long as I finish by going up 2. Okay, so I can, if I want to go over here to -4, and then I can go up 2. So in every single situation, the y-coordinate is 2. So I can put whatever I want for x as long as I go up 2 to finish. And that gives me another point on the line. So then this is what that line looks like. This is the line y equals 2 because every single point has an y-coordinate of 2. And then for vertical lines, it's just true about x. For example, x equals 4. Well, that just says I don't care what the y-coordinate is, I just need the x-coordinate to be a 4. So you can go up or down wherever you want as long as you finish by going right 4, and you're going to get this line right here. Okay? So y equals goes left and right, x equals goes up and down, and you simply pass through the value on that axis. Okay, so give this one a try, these two try, see how you do. Well, here's y equals 3. And here's x equals -4. Just that easy. Just got to remember which is which, okay? So how do you interpret linear functions? So what we're saying is that a story problem has a situation that fits the shape of a line. So it's linear, okay? So in a story problem, the b value is usually a starting value or a beginning. I remember I say begin, b means begin. So think about the beginning value in a problem, okay? For example, admission to the fair cost $8. Well, if you're going to go to the fair, you got to get through the door first. That's the first thing that happens is you pay admission. So you're going to pay that one time, $8. So that beginning value is always something you just pay once. The slope is always a number that compares two units and how they change with respect to each other. This is the one you may pay multiple times. So in fact, if rides at the fair cost $2 per ride, you're going to ride something multiple times and you're going to pay, or you're going to ride several rides. And every time you ride a ride, you're paying two. So you're paying 2 multiple times. That's the slope. That's what's changing. How many times you pay 2. Your cost changes by $2 every time you ride a ride, okay? The x-intercept is usually a total number of units from the problem. Well, the units in this case are rides. So if Carlos rode 12 rides, we're saying the x-intercept is 12, okay? Let's look at this in action here. It says Ryan is in the business of manufacturing phones. He must pay a daily fixed cost to rent the building. What does that sound like? Hopefully that sounds like the B value to you. And also pays a cost per phone. That word per usually tells me it's slope. Okay, so if you see per, it's comparing cost to phones. All right, and that's that rate of change that we're looking for, that slope. Produced from materials and labor. The equation C equals 300 plus 50p can be used to determine the total cost in dollars of producing P phones. So P is the number of phones. That's what's changing here, is how many phones you produce. What is the y-intercept of the equation, and what is its interpretation in the context of the problem? Well, the y-intercept is that value that you pay one time. What cost does he pay one time? Well, that's the $300. This is the y-intercept, 300. And it represents the additional cost to produce phones? No. The fixed cost for rent and equipment? Right there. Daily fixed cost to rent the building and equipment. That's what we need. B. Okay? What would A represent? A is the additional cost to produce each phone. That's cost per phone. Well, that would be slope. The total cost to produce all of the phones. Well, that's C. The number of days to produce all the phones. That is the x-intercept, I believe, right there. Okay. the number of phones produced in a day. That's just P. Okay. All right. Example 5. Claire was given a gift card for a coffee shop. Each morning, Claire uses the card to buy 1 cup of coffee. The amount of money remaining on the card after buying X cups of coffee, so X represents cups of coffee, is given by this equation. What is the x-intercept? And what is its interpretation? Well, how do we find x-intercepts? You remember that? So what is the y value, or in this case, A represents the y value. Okay, so y equals 45 minus 3x. How do we find the x-intercept from that? Well, we make y 0. And what I'll do is I'll just move 3x by adding it to the other side of the equation over here. And I'll get 3x equals 45, and I'll divide by 3. And I get 15. Well, what does that 15 represent? Well, x is cups. So 15 is the number. Is that the amount or the cost for the coffee? No. The total number of coffee purchased from the cards? Yes. Total number of cups. The original amount of money, that's the B value. The tax isn't even in the problem. The amount of each cup of coffee costs, we know what that is. It's 3. Okay. All right. You try this one. All right, so an electrician charges a set fee for every house call. So there's a set fee, that's the B value, for every house call. Charges an hourly rate, that's M, depending on how long the job takes. The total cost of the electrician's services can be determined from the equation C is total cost equals 60T plus 110, where T is the number of hours, so T is hours. What is the y-intercept of the equation? So remember, y-intercept is always the beginning value. In this case, it's the beginning cost. What does it cost to even get that person to come to your house? Well, that's a set fee. Which one of those values is the set fee? Well, it's the one that, this is y equals mx plus b. That's the form it's in, right? So you got to use some of that too. The b value then is the 110. And what does that represent? That's the set fee, that one-time cost for the house call. The number of hours he spends is T. The hourly rate charged is the slope, or 60. Rate is slope. Total cost for all the services, well, that's just the value of C. Okay? You try the next one. Okay, so we've got Camden accepted a new job at a company with a contract guaranteeing annual raises. Camden's salary after working N years can be determined using the equation S equals 200N plus 55,000. What's the slope? Well, here's Y equals MX plus B, and the slope is 2,000. And that slope represents his salary when hired? No, that's the B value, which was 55,000. The number of years Cameron must work for the company? No, that's just the value of N. The raise that he gets each year. So this is dollars per year, and that's what we're looking for. The salary in his nth year working, well, that's just going to be S when N equals a number, okay? That's S. We want the raise he gets each year. That's a rate. Money per year is what that represents. Okay, that's our slope. All right, so if you look at that lesson, Delta Math 5.4, you're going to find 3 things. You're going to find a skill about graphing lines from slope and y-intercept, graphing lines from equations, and interpreting linear function coefficients. In fact, the 3 that we just looked at came right from Delta Math. They're going to look just like those.